This video instruction is for Basic Electricity Chapter 9 assignment. Here you see a copy of the assignment and the information about the test. Here you see question number 1, minimum number of resistors in a compound circuit. And then the next question number 2, this is the diagram. It says in this circuit below, what is the value of IT, or current total? So in order to figure the total current, you have to know voltage and resistance, and then you calculate current from that. So what it's showing here, this dashed line with the 10 ohm resistor, is that the equivalent of this circuit right here, 1 ohm, 6 ohm, 3 ohm, if you add those together, it actually equals 10 ohms. So this is a 10 ohm resistor. And then, of course, when you take two 10 ohm resistors in parallel, now that you've determined this is actually the equivalent here, 10 times 10, 10 plus 10, do the product over the sum, it comes up to 5. So here is the total resistance. I guess the way they show it in here, you're supposed to understand this, but it isn't as clear as maybe it should be. But now we have a circuit where there's an equivalent resistance of this 10 ohm resistor here and these 3 resistors here that is equivalent to 5 ohms, and we can add the 2 ohm, the 5 ohm, the 3 ohm, with a total of 10 ohms, divide that into the total voltage, which is 10, and now we know that the total circuit amperage is 1 amp, and that is the answer to the question. Question number 3, I think most people are getting this one. It's current in the neutral wire is the correct answer. Question number 4. I have to apologize for this one because this is the wrong diagram. This diagram is not the same one that's in the Basic Electricity Answer Book. It's not the one that you should be using for this question. And that is something that I should have noticed by now. If you've noticed in the front of your Basic Electricity book, my name's in there under acknowledgement. So I'm kind of responsible for this class and the Blackboard site and the book. So I will get this changed. It's not the first diagram that I found is wrong, but in the Blackboard course, I'll get this changed. Here is the actual diagram you should be looking at. This is right from the Basic Electricity Answer Book. You see it circled in red there. So the question is, in the circuit below, the voltage drop across the 3 ohm resistor is, and of course, since this is the answer book, it already gives you the answer there, which actually, when you looked at the answers that were available for the Blackboard course, 2.4 volts was not one of the answers. It was actually 2.2 volts, which was a typo. But let's go through and figure out how we came up with the voltage drop across the 3 ohm resistor at being 2.4 volts is what it actually is. So our circuit here at 2 ohm, 3 ohm, and 7 ohm, that has a total resistance of 12 ohms. And if we have 12 ohms parallel with 6 ohms, we can do product over the sum. 6 ohms times 12, 6 plus 12, ends up being 4 ohms. So the total resistance of this circuit here, all 4 of these resistors in this parallel series configuration, is 4 ohms. Now we can add our 1 ohm resistor, our 4 ohm equivalent resistance, and our 5 ohm resistor, and that gives us a total resistance of 10 ohms. And we can take the voltage divided by the total resistance, and we come up with 2.4 amps. That is the current flowing through this part here, and this part here is going to be 2.4 amps. Since we know that the amperage across this 1 ohm resistor is going to be 2.4 amps, we know that the voltage drop is going to be 2.4 volts. 1 ohm times 2.4 amps is 2.4 volts. And the 5 ohm resistor here with 2.4 amps flowing through it is going to create 12 volts of drop. So that total of the 2.4 volts and the 12 volts across these two resistors leaves us with 9.6 volts when you subtract 14.4 from 24. We end up with 9.6 volts is the voltage drop across this 6 ohm resistor, and it's also the voltage drop across this series circuit of 3 resistors. So if we had 12 ohms of total resistance and 9.6 volts, we take 9.6 divided by 12. That tells us that for every ohm of resistance, there's actually 0.8 volts of drop. So if we wanted to find the voltage drop across the 2 ohm resistor, we would multiply 2 times 0.8, and it's 1.6 volts. If we wanted to find the voltage drop across the 3 ohm resistor, it's 3 times 0.8, or 2.4 volts, which ended up being our answer because that was the question, the 3 ohm. And of course, the 7 ohm resistor is 7 times 0.8, or 5.6 volts. And again, if you add these totals up, 1.6, 2.4, that's 4 volts. 4 volts plus 5.6 is our 9.6. So that is our total voltage drop. But this is a little confusing. It was worse because I tried forever to get the correct answer, find the correct answer for the question 4 that's in Blackboard, and obviously that's the wrong diagram, so the answer is not going to work out. So regardless of what you ended up scoring on chapter 9, now that you've seen this video, you should be able to go in and get 100 on it. I'm going to change everybody's score to 100 for chapter 9 because this should have never been this far into the class and not have noticed that there was a problem with this.